Hey, what's up, guys? This is Chung here. So today, let's take a look at LeetCode problem number 491, increasing subsequences. So you're given like an integer array, and you need to find all the different possible increasing subsequences of the given array, and the length of an increasing subsequences should be at least 2. And for example, you're given like this 4, 6, 7, 7, right? And then all the subsequences whose length is at least 2 is like this, 4, 6, and this blah blah blah, right? I mean, for this kind of problem, I think it's kind of obvious that we have to use backtracking, right? Because every time when you are looking when you need to do all the possible arrays, right? You cannot use the DP, right? DP is not designed for that. So for this one, we have to use like the backtracking, right? And so, but keep in mind that there could be a duplicated numbers here, right? And as you guys can see here, so the duplicated numbers, I mean the same numbers, are considered as an increasing part of the increasing sequence as well. And also needs to find the different possible increasing subsequences, right? Okay, so that's gonna add like two more constraints on this problem, right? So but still it can be solved, right? So I mean, to solve this kind of different possible increasing subsequences, I mean the most straightforward way is by using a set. At least in Python, basically, we don't care about we don't worry about the duplicates here, and we're just using a set here, and the set will help us to eliminate the duplicated item for us, right? So all we need to do is that we just need to write our main logic for backtrackings, right? We have current, but but besides this set solutions, I'm also going to talk about solutions without using the set. How can we do it with the regular list here? But let's just do a set here, and since it's most straightforward one. And so what's going to be our ending case, right? And we have to check this ending case every time. Basically, if the length of the current one, right, is greater than 1, then we know, okay, we have one of the answer, right? So we just because the length we're looking for is greater than 1, right? So we just do a length.add, okay? And since we are in the set, we cannot use a list here because the list is unhashable. That's why we have to convert the list to a tuple, right? That's how we handle this in Python, okay? And that's that, right? And then the rest will be what? Will be okay, let me finish the other parts first. We have a backtrack. We start from zeros, and then we start from zero and empty list here. Now, since it's looking for an increasing order, right? So which means that from the current start, from the start and with previous the current values, right? The new the new numbers we are adding to this current has to be either equal or greater than the last one, right? Basically, that's why I'm using this current to -1, right? But because we need to record the last numbers in this current, right? And since this one, it could be empty, right? If it's empty one, then this one will throw an arrow. That's why I'm going to if the current is not empty, else what? Else we just give it like a uh, -200 because it says the range of this given array is only from -100 to 100. That's why I'm giving these numbers here, and and then from I in the range of start and n, right? So this part is just a regular backtracking template, right? And then the so if, right, if the nums I, right, is either equal or greater than the last, right, then we add the one, append this one, the current numbers to the current list, and then we call backtrack, right? Backtrack to what we start from I plus one and do the current, and then here we just pop that out, right? And then oh, we also need the n here, right? So the n is going to be the length of nums. So in the end, we simply return the answer. Yeah, so that's basically the backtracking, right? And if we run the code, yeah, 4, 6. Oh, the sequence is a little bit off, but doesn't really matter. All right, cool. So it passed, right? I mean, like I said, you know, that's we are utilizing the set. What if there's no easy way to using a set? How can we do a list here, right? So the way we're doing the list is that, you know, when we are like looping through from the start to end here, right? We have to record what are the numbers we have seen for this backtracking method, and we only do a backtracking when the number has not been seen before. If it is, then we simply just you know, skip that. That's why I mean here I'm using a scene set here, right? And let's do this, right? If nums I is in scene, right? If it's in the scene, we simply continue, right? Otherwise, we do a backtrackings, and in the end, we add the scene to the add to the we add these numbers to the scene here. That's how we using removing the duplicates number. All right, if we run the code again, should oh yeah. So for that case, you know, here we don't need to use a tuple. We can simply do a insert answer dot append, and here we just do a answer the deep copy of the answer here, right? So all right, cool. So if I submit again, so it also passed. Yeah. And last thing, the time complexity, right? So I think to calculate the backtracking like time complexity is a little bit tricky. But for this one, you know, this one is almost identical to get the subset, right? But it's only just getting the subset with some of the constraints, like the no duplicates and the length has to be at least 2, but the overall time complexity should be the same as the subset. And for the subset, you know, the getting the subset time complexity is going to be the 2 to the power of n, right? And which n is the length of the numbers here. And why is that, right? Because for getting the subset, you know, the easiest way to figure out the time complexity is for each numbers there are only two options. Either the number exists in the subset or the number does not exist in the subset. That's why we have a 2 times 2 times 2 until we have n twos, right? That's why sorry, there are like total of n twos. That's why the total time complexity to getting a subset is 2 to the power of n. Yeah, cool. I think that's it for this problem. And thank you for watching the video, guys, and stay tuned. I'll see you guys soon. Bye bye.